All right, guys, this is part 2 of our diagramming data, and let's move on to our last 2 types of ways that we can diagram data that we'll talk about today. First is a box and whisker diagram. So a box and whisker diagram is a line segment that shows the highest and lowest numbers, and then the upper and lower quartiles in the median of a set of data. We'll talk about how to find the upper and lower quartiles next. You should already know how to find the median. Just as a reminder, if you arrange all of your data from the lowest number to the highest number, or least to greatest, your median is going to be the one that's smack dab in the middle of that list of numbers. Think of it when you talk about like the median of a road, that's the center cement part or the line part that's in the middle of the 2 lanes. That's our median right in the middle. So it shows our highest, our lowest, our median, and upper and lower quartiles. The quartile is one of 3 values, any one of 3 values that divide the data into 4 equally sized groups. Should have gotten that out of the word quart or quartile here, meaning 4. So one of the 3 values that divide the data into 4 equally sized groups. Our lower quartile is the median for the lower half of the data. So again, we're going to list all of our numbers. We're going to find out where the median is, the half. And then in the lower quartile, we'll find the median of just that half. Hopefully, then you can guess that the middle quartile is the median for all of the data. And our upper quartile is the median for the upper half of the data. So we've got 3 different medians: the median of all the data, the median of the bottom half, and the median of the upper half. So let's see what that looks like with these numbers. The numbers below represent the pages read yesterday by 12 students in this class. We're going to find the lower, middle, and upper quartiles. So somebody read 16 pages, somebody read 51 pages, somebody read 46 pages. So the first thing we would have to do is to put our numbers in order from least to greatest. So that will give us our upper and our lower bounds here. So here they are, from upper to lower, although, yeah, there we go. Wanted to make sure those were the right numbers. So 16, 29, 29, 30, etc. Right, so those are our numbers. We're going to find the middle quartile by finding that's our median. And we've got an even number here. We've got 12 numbers. So the way that we find the median, since there's no number right here in between 39 and 40, we have to find 39 plus 40 and divide it into what's the number that's halfway between 39 and 40. And just, you should know that logically, that's 39.5. So that's going to be our median of our whole data set, also called our middle quartile. To find our lower quartile, we take a look at the lowest half here. So that's the numbers 16 to 39. And we find the middle or the median of that group of numbers. Again, we've got 6 numbers. So in the middle, we've got 29 and 30. We need to know what comes halfway between 29 and 30. So we add them and divide it by 2, and that gives us 29.5. And for our upper quartile, again, we've got 6 pieces of information here. So we've got 46 and 50. We need to know what comes right in between or halfway between 46 and 50. So we add 46 plus 50, divide it by 2, and halfway between 46 and 50 is 48. So those are our middle quartile, which is our median of the whole data set, our lower quartile, which is the median of the lower half of data, and the upper quartile is the median of the upper half or the upper range of our data here. We're then going to use that information to construct a box and whisker diagram for the data in the last example. So first we need to make our line segment here. On the left-hand side, we put our lowest number, which was 16, and on the right-hand side, we put our highest number, which was 70. Our middle quartile or median goes right there in the middle at 39.5, and then we place our lower and our upper quartiles accordingly where they would go on the number line. From there, we draw a box to show our lower quartile, middle quartile, and upper quartile here. And most of our data is going to fall inside that box, inside that range of 29.5 to 48. So that is a box and whisker plot, or box and whisker diagram is another name for it. The interquartile range, when you hear us talking about the interquartile range, that's the difference between the upper and lower quartile. So if we go back to this example here, Our upper quartile is 48, and our lower quartile is 29.5. Our interquartile range would be the difference between those two numbers. While the range for a whole set of data would be from 70 to 16, the interquartile range is just really the amount that's in that box. So let's see how you do here. We're going to construct a box and whisker diagram for this data set and then calculate the interquartile range. So the first thing we want to do is to list our numbers in order from least to greatest. So here they are from least to greatest. There are 11 numbers here, which makes finding our median and our lower and upper quartile really easy. So our middle quartile, if you remember, is the median. So that's 1, 2, 3, 4, 5. 5 from the left, and 1, 2, 3, 4, 5 from the right. That gets us our middle quartile, 28. Our lower quartile would be the median of these 5 numbers. Well, right in the middle of these 5 numbers is 22. And our upper quartile, again, 5 numbers, in the middle of those 5 numbers is 32. So we've got 22, 28, and 32. Our interquartile range would then be the difference between the 32 and the 22, and that would be a 10. So the amount of space that the box would take up on our line segment would be 10 units, and it would look like this. 12 is our lowest, 35 is our highest, and you can see the box here is a little bit closer to 35 than to 12. Our last type of diagram that we're going to talk about in our class is a stem and leaf diagram. It's a type of bar graph, or similar to a bar graph, in which the data points in each interval are listed in order. We're going to make a stem and leaf diagram for the following set of data, which represents the number of pages, again, read by 12 students. It's just easier to understand a stem and leaf if you see it than it is to explain it here. So you can see we've got number of pages read, and this represents the first number. So that 1 represents the tens place. So 1 and 6 is 16, 2 and 9 is 29, and 2 and 9 is 29. Then we have 30, 35, and 39, 40, 44, and 46, 50, 51, and 70. So it shows you all of the different data points in that, it's not a category, how did we say it? In that interval. So in the 10 to 19 interval, this is how many people read. Just one person read 16 pages. In the 20 to 29 interval, we've got these. So you can see very quickly that most people read in the 30 or 40 page range. A few people read less and a few people read more, but the majority of what people have read are in that 30 to 40 page range. If we back up here to our box and whisker diagram of that same information, you can see again most of our people here read in that 30 to 40 page range. So this is 29.5 to 48. So 30 and 40. So that stem and leaf diagram just confirms what we already saw in a box and whisker diagram. It just shows that information a little bit differently by listing each answer in an interval, or each piece of data in the interval. Right, on your own, see if you can make a stem and leaf diagram for the following set of data. Maybe these numbers represent the weights of different people in the classroom. Again, what we're going to do is show it by intervals. So we might make a 120 interval, a 130 interval, a 140 interval, 150, and a 160 interval. So it would look something like this. And this shows us that if these were weights, for example, that most people are in the 120 or 140 category. And the majority of our weight, or the majority of the people that we're weighing, are below 149, if that's what this data represented. All right, guys, so we did a lot today. We read and we deciphered data from bar and line graphs. We also looked at histographs or histograms. We looked at pie graphs. We looked at dot plots. We looked at pictographs. We looked at box and whisker plots, or box and whisker diagrams, and finally stem and leaf plots. And all of these are ways that we can diagram or show the data that we've collected so that it's easy for other people to read and to understand. We've got one last definition on your notes, but we'll talk about that in class. Make sure if you have any questions that you write those down. See you next class.